This is problem number 5 from the H8-6 homework. It says, write a possible equation in factored form, given it has single roots at 5, 0, and negative 1, 0, and a double root at negative 3, 0. Sketch a graph of the polynomial. All right, so this is a possible equation. That means that there isn't one exact answer. Okay, so let's just take this here. We know that this is a single root. We know that negative 1 is a single root. And then we have the double root at negative 3, 0. Okay, so there's nothing in here about a stretch factor. So we can take this here and turn this into an equation and give the graph. So if I have, a root at x is equal to 5, right? These are the roots. I have one at negative 1, and I have a double root at x is equal to negative 3, okay? So, you could even take that and list that as x equals negative 3 twice if you wanted. We know the factor this comes from when we move 5 back across the x. So our factors here, the x minus 5. We'd have an x plus 1, and then we'd have an x plus 3 and another x plus 3. But we can take those x plus 3's and we can combine them into the quantity of x plus 3 squared. And now let's just go ahead here and add in our other two factors. We have x plus 1, and I have x minus 5. So this one has no mention at all of a stretch factor or its orientation. So I'm going to just leave it as a positive function there. And this would be the factored form that I'm looking for. Okay, and then if I'm asked to graph it, okay, I'm going to just go ahead and put my x-axis on here. My roots were at negative 3. I had one at negative 1, and I had one at positive 5 there. Okay, so if I'm taking this here, my equation that I've given is positive, so I know that I'm going to end going up here, right? Which means since it's a degree of 1, 2, 3, 4, since it's a degree of 4, right, we're going to be starting from the top as well. So I'm going to come down here. I know at negative 3, right, at negative 3 here, it would bounce, and then the other ones would go straight through. So I'm going to come down from here. I'm going to get to the x-axis. I'm going to bounce off, come up. I'm going to come straight down through negative 1. I'm going to end up curving here, and then I'm going to go straight through my point at positive 5. Throw my arrows on, and that is one possible graph. If your graph ended up being, the opposite of that, where it's flipped and going down, that would be correct. Just make sure you include a negative in the equation that you've started on the left side. All right, that is problem number 5 from H8-6 on the homework. If you have questions still, please make sure you contact me. Otherwise, keep on rolling.